Today we're going to talk about a couple of new formulas for a concept that we're already pretty familiar with, which is the area of a triangle. Now, we already know one formula for the area of a triangle, hopefully you remember. The area is 1/2 the base times the height. Now, what we probably have noticed in the past working with this area formula is that the height is usually the problem. We either don't have it or it's kind of difficult to get. So what we want to do today is make a new formula, kind of create one, that doesn't require the use of the height. So here's what we're going to do. I'm going to replace that height. So we've got any triangle. I don't know what it is, so we're going to name it ABC to be kind of general. And now, if this triangle is named ABC, then the sides are also named lowercase a, b, and c. And what I want to do, again, is get rid of the height in the formula. So we need to know how big is the height in this triangle. So if I go ahead and actually draw in an altitude, draw in a height in this triangle, it's going to make two right triangles, and we can call this h for that length. So how big is the height? Well, we can use trigonometry to figure that out. So if I look at one of these triangles, say the right triangle on the left, then I can talk about angle A and perhaps the sine of angle A. So the sine of angle A, we know the sine relationship is the opposite side to the hypotenuse. So in this case, the height to side C. So height to side C. Now, if what I'm trying to do is get rid of the height in the old formula, then I can take this new one and solve for h. So we can just multiply by c on both sides, and we get c times the sine of A is going to be the measure of the height. So what I can do now is replace in my old formula the height with this c times the sine of A. So 1/2 b, my base, because b is the measure of the base down here, times the height, which now is c, times the sine of angle A. Now, because I've got this capital A in here that means angle A, I can't use A for the area anymore. So you'll see one of two things. We'll actually write out the word area, or sometimes we'll use another letter. Very often K is the letter we'll use here. So K equals, K meaning area, 1/2 times B times C times the sine of A. And so here is your new formula for the area of a triangle. Okay. And again, K just means the area, so we don't have to use A for that anymore. Now, B and C and A, we sort of pick them arbitrarily. We don't necessarily know that the three angles in the triangle are going to be named B and C and A. But the thing that we want to take from this is that B and C in this triangle here are two of the sides, and A is specifically the angle in between them. So the way this angle formula, or the area formula, works is that I have two sides and then the sine of the angle in between. Okay, so what we want to keep in mind is that the information we need must be in side angle side form in order to make this formula work. Now here's what the formula actually looks like. I've got a triangle and I know two sides. I've got 12 and 18, and I've got the measure of the angle in between them, so this works. And so all I have to do is plug these numbers into the formula. So my area, again we're going to call it K for now, is equal to 1/2 the measure of one side times the measure of another side times the sine of the angle in between them. So the sine of 94 in this case. And nice and simply, all we have to do is put this right into the calculator. And so in this case, the area of this triangle is 107.7 square units. Okay. Now, I can extend this beyond just triangles, which is kind of cool. I can talk about maybe the area of a parallelogram. So, for the area of a parallelogram, what I have is, well, I don't have a triangle, but what I can do is look and see, well, I've got a triangle in here. I can kind of imagine this triangle ADB for now, just that piece of it. So we've got ADB, and side D is 16, Side B is 10. And then the measure of angle A we've got is 60 degrees. So I can use the area formula to find the area of that triangle. So the area of that triangle is 1/2 the measure of one side times the measure of another side times the sine of the angle in between them. And again, right into the calculator. So we're going to get about 69.3 square units. Now again, that's going to be the area of the triangle, not the whole parallelogram. But if we're looking at the picture here, we can see what the relationship between the triangle and the parallelogram is. See, what we just found was the area of this triangle, and the rest of the parallelogram is another triangle that's perfectly identical to the first one. So if I just double the area of that triangle, then I'll have the area of the parallelogram. So very simply, all we have to do to find the area of the parallelogram is multiply that old area by 2. So 2 times my old area will give me the area of the parallelogram, which is approximately 138.6 square units. Now, this is one formula. We actually have a third formula that we can use to find the area of a triangle, and that's called Heron's formula. Now, there is an example of where the Heron's formula comes from in your textbook. It's on page 653, but for now I'm just going to give it to you. And what we need is just to know all three sides. We actually don't need any angles to use Heron's formula. Now the area for Heron's formula is the square root of s times s minus a times s minus b times s minus c. Now, the A, B, and C in here are the three sides of the triangle that we've been seeing before. The S is something new. The S is a new value that we can calculate, and that's actually the perimeter of the triangle, so A plus B plus C, all divided by 2. So 1/2 the perimeter, that's going to be my value of S. S is something that we call a parameter. So I'm going to have to calculate it for each problem that we do. Parameter. Make that a little neater. Now, its value, we're going to calculate it for each problem, but it's always going to come from the same formula, and we do need to calculate it before we can move forward with the formula. So here's an example of how Heron's formula works. I know that the area, again, is the square root of s times s minus a times s minus b times s minus c. So first thing I'm going to have to do is calculate s, and we said that's the three sides added up and divided by 2. So 43 plus 53 plus 72, all divided by 2, is going to give me the value of s. So in this case, for this problem, that s is 84. So now I can plug that in. The 84 is going to go in the 4 places where s goes. And then A, B, and C, again, are the 3 original sides of the triangle. So we can go ahead and plug all of those in. So 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. Make sure all of that's under the radical, and then we can simplify, and we'll do that in a couple of steps just to make our lives a little bit easier. So we've got 84 times the first difference, 84 minus 43, which is 41, times the second difference, 84 minus 53, which is 31, times the third difference, 84 minus 72, which is 12. So we can multiply these four numbers inside the radical, get a really large number, 1,281,168. And then square root that in the calculator, and we get the area of the triangle, which is approximately 1,131.9 square meters. So, there are a couple more problems at the bottom of the page that ask you to pick which formula is better. So is the new area formula with the sign in it better, or is the Heron's formula better? Give those two problems a try. The answers will be on the portal, and you'll get some more practice using these two formulas in class tomorrow.